Welcome to this class. This session, we are going to give an example to illustrate how to prove that a given function is harmonic. So example, show that the function given by e raised power, so u of x comma y, e raised power minus 2xy into sine of x squared minus y squared is harmonic. So to show that the function is harmonic, we simply show that it satisfies the Laplace equation. So that's the task. So solution, we show that partial squared u partial x squared plus partial squared u partial y squared is 0. That's how we prove that a function is harmonic. So thus, we start by partial u partial x. So remember this, the u is minus 2xy sine of x squared minus y squared. So we use product rule, whereby we let this exponential to be u and this to be the v function. So u prime, you will have to differentiate this power with respect to x. That will give us minus 2y, and then e raised power minus 2xy, and you multiply by sine of x squared minus y squared. Plus v prime u, so v prime, differentiate this part with respect to x, we get 2x, and then differentiating sine function will be cosine, and so we'll have e raised power minus 2xy, and then cosine of x squared minus y squared. Then partial u partial y will be, so same thing, use product rule, u prime, so differentiate this part, we get minus 2x e raised power minus 2xy, and then sine of x squared minus y squared. This part plus u v prime u, but this will give us minus 2y, so this will have a negative sign, minus 2y e raised power minus 2xy. Differentiating cos function, we get a cos, a sine function, we get a cos function. So remember the process, what we are doing here, we are just using chain rule. So if you say this is equation 1, this is equation 2. Now we also differentiate 1 with respect to x to get second derivative with respect to x. So partial squared u partial x squared. So differentiate this one here. Same process of this part. Let this one to be u, so that you'll have, differentiating this part, you'll have minus 2y. So multiply by this one, you have now positive 4y squared e raised power minus 2xy, and then sine of x squared minus y squared, and then differentiating this part with respect to x, we get 2x, and then 2x times this one will give us minus 4xy, and then e raised to minus 2xy. Differentiating the cost function, sine function, you get a cost function. So we have done with this first part. Second part, so we let this one to be, can actually split it into two parts. So this to be u, then this other part to be v. So u prime, this part here, we'll also use product rule so that we have, this one is like now our u still, so it should be 2, and then e raised power, because this differentiating 2x, we just get 2. E raised power minus 2xy. And then this part, when you differentiate, you get minus 2y multiplied by 2x, you get minus 4xy, e raised power minus 2xy. And then you multiply by v, which is this function here. So we'll have 2 e raised power minus 2xy minus 4xy, e raised power minus 2xy. You multiply by cosine of x squared minus y squared. Now, you again now differentiate this one. So this will give us 2x, and then that 2x times everything here. So we'll have 4x squared, e raised power minus 2xy. Derivative of our cosine function is a negative sine function. So this is a negative sign, and then sine x squared minus y squared. So that's for partial squared, partial u, partial squared u, partial x squared. And then partial squared u, partial y squared. So let's start with this part here. Let this to be u, and then this other part to be v. So u prime, this part with respect to y, is with minus 2x. So we have positive 4x squared, e raised to minus 2xy, and then multiply by sine of x squared minus y squared. And then differentiating this one, we get minus 2y. Multiplied by this one, we get now plus 4xy. And then e raised to minus 2xy. When you differentiate a sine function, you get a cos function. This minus. So we have done derivative of the first part. So x squared minus y squared. Now we come to this other part. We also let this part to be u, and then this one to be v. So u prime will actually also be involving another differentiation by product rule. So letting this be small u, so derivative of this part will be 2y, so 2, and then e raised to minus 2xy. Differentiating this one, we get minus 2x. So multiply by this one, you get plus 4xy. And then this, you multiply by cos of x squared minus y squared. So we'll have, there's a minus sign here. So then minus into, or I can just put the negative sign directly. So because there's a negative sign here, so then just write negative of everything negative here. So we'll have negative of 2 e raised power minus 2xy, and then multiply by cosine of x squared minus y squared. And then also negative on this part will be negative 4xy. Remember that, so we have another e raised power minus 2xy here. So remember when you say the derivative of this power is minus 2x, and then if we multiply by this one, so it'll be 4xy, 10 times the same thing. So minus 2xy, and then cosine of x squared minus y squared. And then the derivative of this part with respect to y will be minus, the derivative of a cost function is a negative sign, so it will make this sign to be plus, but the derivative of this bracket here is minus 2y. So therefore, we'll still have a negative, so it'll be negative. That's 2y times this one to give us now 4y squared e raised power minus 2xy. And then this cos becomes sine, then x squared minus y squared. So let this one to be called equation 4. This one for partial squared, u partial x squared, or this one, call this one equation 3, or this one equation 4. So then now, 3 plus 4, you see we'll have this for y squared e raised power minus 2xy sine x squared minus y squared. So I've taken this term, and then I come and check, because I'm adding these two, so I'll come and take this one minus 4y squared e raised power minus 2xy sine of x squared minus y squared. So I've also taken care of this. Next one, I have this minus 4xy e raised power minus x minus 2xy cos x squared minus y squared. So I've taken this. I come and then pick this one here, plus 4xy e raised power minus 2xy cosine of x squared minus y squared. So I've taken this term. Here, I pick this and multiply by this one, so plus 2 e raised power minus 2xy multiplied by cosine of x squared minus y squared. So I've taken this term with this one here, and then I come and pick this one here, minus 2 e raised power minus 2xy cos of x squared minus y squared. So I've taken this and this one here. And then here I have this minus 4xy. And then e raised power minus 2xy multiplied by cosine of x squared minus y squared. So I've taken this, I bring it So this minus, and here I have a minus sign. So this term here, so partial squared y. So we had 4xy. There's a minus sign here. So when we have this, is what we did. So minus 2y. So then we had differentiating this one, we get 2, and then e raised power then cosine of that one. The derivative of this part, when you differentiate this term here with respect to y, you'll have minus 2x. When you pre-multiply by this negative sign here, you get positive. So this must be plus. Because we'll have now minus 2x multiplied by minus 2y. So this will be plus, not minus. So therefore, that one will be, take this one. So plus 4x y e raised to minus 2xy, and then cosine of x squared minus y squared. And it should be clear that all these things are going to 0 because we have pairs of terms which are the same and have opposite signs. So this one gives us 0. So here we have 0. And then this term and this term also gives us 0. Same terms with opposite signs. And then this term also gives us 0. And finally, this term, and this term gives us 0. So 0 plus 0 plus 0 gives us 0. So 0 plus 0 plus 0 gives us 0. And that was what we have to prove. So thank you.